Today we learn how to work with functions like x squared, x cubed, x to the fourth, and so on. These are called power functions because x is raised to a power. A quick foundation check. X squared means x times x. X cubed means x times x times x. X to the fifth is x multiplied by itself 5 times. That is all you need to start. Consider a function y equals x cubed. This creates a curve when graphed. The question is, how fast is this function changing at any particular point? Think of riding a bike up a hill. At steep sections, the function is changing fast. At gentle sections, it is changing slowly. The derivative tells us exactly how steep the hill is at any specific point. A derivative is the rate of change, or the slope. When we differentiate a function, we are asking how fast it is changing at a given moment. Let us look at some examples and spot the pattern. If y equals x to the first power, which is just x, the derivative is 1. We write dy dx equals 1. If y equals x squared, the derivative is 2x. We write dy dx equals 2x. If y equals x cubed, the derivative is 3x squared. We write dy dx equals 3x squared. The pattern. The exponent comes down as a multiplier, and the exponent decreases by 1. The power rule formula. If y equals x to the n, then dy dx equals n times x to the n minus 1. Take the exponent n, multiply your function by it, and reduce the exponent by 1. For y equals x to the seventh, take the 7 and put it in front, reduce the exponent from 7 to 6, and the answer is dy dx equals 7x to the sixth. What about constants? If y equals 5x cubed, the constant stays and comes along for the ride. Apply the power rule to x cubed to get 3x squared. Multiply by 5 to get 15x squared. The answer is dy dx equals 15x squared. What if y equals 7, just a number with no x? A constant does not change. It sits at 7 forever. No change means the derivative is 0. If y equals 7, then dy dx equals 0. A flat horizontal line has no slope, no steepness, no change. Why does this pattern work? We want to know how fast y is changing when x changes. Start at some value of x. Move a tiny bit to the right by an amount called delta x. See how much y changed, which is delta y. Calculate the ratio delta y over delta x, change in y divided by change in x. Make delta x approach 0 and see what remains. A physical analogy. If you drive 100 miles in 2 hours, your average speed is 50 miles per hour. But what if you want your speed at one exact moment? You would look at a tiny time interval, maybe 1 second, and see how far you went. The derivative is exactly this. The instantaneous rate of change. When the math is done carefully, using the binomial theorem to expand x plus delta x to the n, all the terms with delta x disappear when delta x gets very small. What remains is exactly n times x to the n minus 1. Integration means going backwards. If someone says the derivative is 3x squared, can you figure out what the original function was? When differentiating, the exponent comes down and decreases by 1. To go backwards, do the opposite. Increase the exponent by 1 and divide by the new exponent. The integration rule. If dy dx equals x to the n, then y equals x to the n plus 1 divided by n plus 1 plus c. What is that plus c? When you differentiate, constants disappear. If y equals x cubed plus 5, then dy dx equals 3x squared. If y equals x cubed plus 100, then dy dx equals 3x squared. If y equals x cubed minus 27, then dy dx equals 3x squared. They all have the same derivative. When you integrate, you do not know what constant was there originally. The plus c represents some constant that is unknown. Example: if dy dx equals x to the fifth, find y. Increase the exponent from 5 to 6. Divide by the new exponent to get x to the sixth over 6. Add c. The answer is y equals x to the sixth over 6 plus c. Example: if dy dx equals 4x cubed, find y. Ignore the 4 temporarily. Integrate x cubed by increasing the exponent to 4 and dividing by 4 to get x to the fourth over 4. Multiply by 4 to get x to the fourth. Add c. The answer is y equals x to the fourth plus c. Integration uses a symbol that looks like a stretched s. The integral of x cubed dx equals x to the fourth over 4 plus c. This reads, the integral of x cubed with respect to x equals x to the fourth over 4 plus c. The dx at the end means we are integrating with respect to x. So far, we have looked at whole number powers like x squared, x cubed, x to the fifth. What about x to the 1/2? X to the 1/2 is the square root of x. X to the 1/3 is the cube root of x. X to the 2/3 means the cube root of x squared. X to the 3/2 means the square root of x cubed. The power rule works even when n is a fraction. Find the derivative of y equals x to the 1/2, which is the square root of x. The exponent 1/2 comes down as a multiplier. Reduce the exponent from 1/2 to -1/2. The result is dy dx equals 1/2 times x to the -1/2. What does x to the -1/2 mean? Negative exponents mean 1 over. X to the -1/2 equals 1 over x to the 1/2, which equals 1 over the square root of x. So, the derivative of the square root of x is dy dx equals 1 over 2 times the square root of x. This makes sense. The graph of y equals square root of x starts steep near x equals 0, then gradually gets flatter. The derivative 1 over 2 root x is large when x is small, meaning a steep slope, and gets smaller as x gets larger, meaning a flatter slope. A note about x equals 0. When y equals square root of x, the derivative is 1 over 2 root x. At x equals 0, we would have 1 over 2 root 0, which equals 1 over 0. This is undefined. The tangent line at x equals 0 is vertical. It has no defined slope. The curve is infinitely steep at that point. Integration works the same way with fractional powers. If dy dx equals x to the 1/2, find y. Increase the exponent from 1/2 to 3/2. Divide by the new exponent. x to the 3 halves divided by 3 halves equals 2/3 times x to the 3 halves. Add C. The answer is y equals 2/3 x to the 3 halves plus c. Dividing by a fraction. Dividing by 3 halves is the same as multiplying by 2/3. What does this all mean practically? If you have a cube with side length x, the volume is v equals x cubed. The derivative dv dx equals 3x squared tells you how fast the volume changes when you change the side length. 3x squared is exactly 3 times the area of one face, which is x squared. This is because a cube has 3 dimensions that all increase. When something falls, the distance fallen is related to time squared. Taking the derivative gives velocity. Taking the derivative again gives acceleration. This is how physics uses calculus to connect position, velocity, and acceleration. Differentiation tells you how fast things are changing. Rates, slopes, velocities. Integration tells you the accumulated total. Areas, distances, quantities. They are opposite operations like addition and subtraction or multiplication and division. Common mistakes to avoid. Mistake 1. Forgetting to reduce the exponent. Wrong. If y equals x to the 5th, then dy dx equals 5x to the 5th. Right. If y equals x to the 5th, then dy dx equals 5x to the 4th. The exponent always decreases by 1 when differentiating. Mistake 2. Forgetting plus c in integration. Wrong. The integral of x squared dx equals x cubed over 3. Right. The integral of x squared dx equals x cubed over 3 plus c. Never forget the plus c. Mistake 3. Mishandling constants. Wrong. If y equals 3x squared, then dy dx equals 3x. Right. If y equals 3x squared, then dy dx equals 6x. The constant multiplies with the coefficient from the power rule. 3 times 2 equals 6. Mistake 4. Confusing the power rule with other operations. The power rule only works for powers of x. Y equals x to the 5th, use the power rule. Y equals 5 to the x, cannot use the power rule. This is an exponential function. Y equals sine of x, cannot use the power rule. This is a trigonometric function. For differentiation, if y equals a times x to the n, then dy dx equals n times a times x to the n minus 1. Bring the exponent down as a multiplier. Multiply by any constant. Reduce the exponent by 1. For integration, if dy dx equals a times x to the n, then y equals a times x to the n plus 1 divided by n plus 1 plus c. Increase the exponent by 1. Divide by the new exponent. Keep constants as multipliers. Always add plus c. Special cases. The derivative of a constant is 0. You cannot divide by 0, so n cannot equal -1 for integration. The derivative might not exist at certain points, like x equals 0 for the square root of x. The power rule is used in physics, engineering, economics, biology, and computer science. Anywhere things change, and that change needs to be measured.